This week at Online CodeReach, we're going to learn about functions and start our simple game. A reminder that I can't hear or see you, so if you have a question, you need to send it through the live chat and we'll help you out. A function is like an input-output machine. They help you organize your code, and more importantly, they help you avoid repetitive code. To create a function, we start off with the keyword def, followed by the name of your function. You want the name of your function to make sense and reflect what it does. Let's look at the example, say hello, which prints out hello world. This creates a function that you can use anywhere in your program. When we call our function, it executes everything inside of it. To call a function, you just type in the name you defined it as, followed with empty parentheses. All variables declared inside of a function don't exist outside of it. In general, what happens inside of a function stays inside the function. If you tried running the code to the right, you would see that it won't work because the variables only exist inside the function. Okay, let's talk about some built-in Python functions. So Python itself has some functions that you can use all the time. For example, the ones that you're seeing displayed on the screen. They work in the exact same way as the functions that you write. Now, what if we wanted a function that could take in an input? To do this, we can include parameters. Parameters work like the inputs for your program. For example, let's make a program that adds win to whatever number you give it. Return tells Python what value to output. This means that if you were to print the function, you would be printing the return value of the function. We can think of our function as like a box, into which we can pass in a number, and then it spits out the new number. Just to clarify, the return value doesn't actually print itself. You'd have to print out the value returned by the function in order to actually see it. And here's some more stuff about the keyword return. Return exits the function. Let's look at an example. If the mark that we passed in was greater than 70, it would stop running at the line return B. If the mark doesn't satisfy any of the if statements, it reaches the line return fail and exits the function. Also, notice that we use return B, not print B. So if you just did average 70, nothing would happen. You'd have to actually print it out by using print average 70 in order to see a result. And now I'm going to give you guys, let's say 15 minutes to do this exercise before we continue. The solution for this question will be ready on Edmodo after you guys tried it out. Okay, let's talk about our simple game. Us CodeReach teachers decided that we were going to make a simple space shooter game with you guys. Today, I'll be guiding you through the process of making a movement function for the player, which is the rocket ship, and the enemies. First, I'm going to give you guys 20 minutes to try and make your own function for moving the player. We start off with a basic graphics program setup, and I load in the image of my player. I then use the built-in transform.scale function in order to make my image the size I want it to be, which is 50 pixels by 50 pixels. Next, I set up the starting position for my player. So my player X value starts at 350, which changes with the left and right arrows throughout the game, and then the player Y would be 540. Let's create our move player function. First, you check if the right key is being pressed down. So if it is, then you check to see if the player has already hit the rightmost wall. This means that the player's X value has to be less than 750 in order for you to move it farther to the right. We pick the value 750 because the width of the ship is 50 pixels. And because stuff is always measured from the top left corner in computers, we need to leave that 50 pixels of space. Then we check to see if the left key is being pressed down. If it is, we need to make sure that the player isn't already all the way against the left side wall. That's why we check to see if the player's X value is still greater than 0. If neither one of those keys is being pressed down, then we just return the player's X value with no changes. Let's look at how we use this function. Here we have the beginning of our while running loop. We set our click value to false, and then we have our event loop. If the event type is key down, we check the states of all the keys on our keyboard. If the type is key up, then click is now true because you actually clicked on a key, and you recheck the states of every key on your keyboard. Finally, if the type is quit, you exit your program. On the right side, we have the rest of our code. We have a screen.fill, which constantly repaints the screen in black, and we draw our player using the built-in function of screen.blit. We have our player image and the player's X value and the Y value. And here we see where we use our movePlayer function. Recall that we only return values, which means that we have to set it to a variable. So we set our player's X value to the new moved player's value. Now we need to figure out how to move the enemies. The way they move side to side is very similar to the player's motion, but they also move down a row every time they hit the left or right wall. Here I load my image of the enemy, and then I transform the image into 40 pixels by 40 pixels. Down here, I set up the position of all my enemies. I have a list that will hold the coordinates of each enemy, and I have a value called start enemy that will help me determine when it's time to change directions. I also have an add value, which is how much to the left or right the enemy is going to move every loop. Okay, here I set up the coordinates of each enemy. So I know I'm going to have 3 rows of them, and there's going to be 10 of them in each row. By using I times 50 as the X coordinate, each enemy is going to be spaced 10 pixels apart because they're 40 pixels in width. So every pair of coordinates is a list. This means that enemy's position at 0 is the X coordinate of the first enemy, and enemy's position at 0, 1 is the Y coordinate of the first enemy. Alright, we're going to build the functions for our enemies. So first we have our move enemy side, which is going to move each individual enemy back and forth. We have our for loop that goes through each enemy and adds on the movement value to its X coordinate that will move it either to the right or to the left. A question that should pop up in your head is, why isn't there a return value? Before I told you, a return value doesn't really do anything unless you print it out or you store it in memory. I lied, because in this case, since you're working with lists, you are actually changing the value at that spot in memory, so it's still stored and you're perfectly fine. I'll give you a bit of time to ask questions about that after I present all 3 functions. Our second function is change direction. This checks to see if the enemies have hit the right or left side. This is where our value of start enemy is important, because it checks how far to the left or right the entire group of enemies has moved. If it reached 0 or 300, that means that either the leftmost enemy hit the left wall or the rightmost enemy hit the right wall, and you're supposed to move the entire group of enemies down a row. You also need to change the direction that the enemies are moving in, and that's why you multiply add by -1. This means that if you were originally moving to the right, which means that you're adding, since you're multiplying add by -1, you're going to be subtracting. With the same logic, if you're moving to the left, which means that you were originally subtracting, and you multiply by -1, you're going to be adding. If you haven't hit either wall yet, you just return the original add value. And finally, we have our move enemy down function. Our for loop goes through the entire list of enemies and adds 20 to each of their y coordinates. Alright, let's finish this lesson by looking at how we use these enemy functions. So to draw our enemies, we loop through the list of the positions of them, and we blit the enemy picture at every position. Then to move them, we call our function of move enemy side. Remember, we don't have to set this to a variable or anything because it's manipulating a list. We add the amount we're moving to start enemy, and we set our add value to the return value of change direction. I also added a time.wait at the bottom of my code that kind of slows down the player and the enemy's movement. This code is up on Edmodo for you guys if you want to check it out. That's all I have for you for this week, and now we're going to be around for the next half hour or so to answer any questions that you might have. I encourage you to review this week's lesson so that you're extra prepared for next week.